Okay, so let's just move on with the theoretical stuff, whatever they are. So permutations. Now you can see on your screens very well that permutations. Anyways, let's just read out what they have written for us. An arrangement that can be made by taking some or all of a number of things. An arrangement. Let me just box it up. An arrangement that can be made by taking some, sum or all of a number of things is called permutation. Okay. Symbolically, the number of permutation of n different things taken r at a time is denoted by PNR or NPR. NPR, P of n comma r or NPR. You can just read it. This also PNR, NPR, and this also NPR. There is no such difference. It's just the different way of writing. It is read as NPR. Okay, do not stress. Okay, NPR. In other words, a permutation NPR is an arrangement in definite order. Now this is very much important for you guys to understand. Definite order of n object taken r at a time. Definite order is why we have so many different arrangement. Order is what makes the arrangement different. While arranging chairs, you consider some order. While you making the queue, you consider definite order. छोटे से बड़ा, सबसे लंबा जो है वो पीछे खड़ा रहेगा, सबसे छोटा जो है वो सामने खड़ा रहेगा. और you are considering group of group of people. So that while arranging them also, you consider that every group should have 2 boys and 2 girls. So there is an order in which the groups have been divided. Anywhere there is an arrangement, there is some or the other order. So there is some or the other arrangement, some or the other order in which the arrangement is made. So while talking about permutation, order is very much important. Now the formula we have already discussed, not a big deal for us now. Since we do not go with formula directly, what we do is we draw the blanks, we solve the answers. But sometimes we might go with this formula also, because sometimes the things are so big that we don't have to draw the diagrams. We just have to we'll just directly put the values and we'll evaluate the answer. So I'm not completely telling you to ignore the formula entirely. I'm just telling you guys, you should use the logical aspect over here. Okay, so what the formula tells us that P of n comma r or NPR is nothing but equal to n factorial divided by n minus r factorial. So if you cannot see them, let me zoom it. Now you can. So NPR is nothing but n factorial upon n minus r factorial. And the good news is that we have derived this formula. You don't have to learn this. You just know how this formula came. तुमको ये मैंने logically बताया है, मैंने proof नहीं बताया exactly. I have logically explained you. Where did it came from? How did it came? ये मैंने वैसा बताया है तुमको. And you just don't have to remember now. You know what the formula is. So that's the beauty of this. That's the beauty of this chapter. Okay, now why don't we just before going to get along with these kind of examples, I'll just take few examples based on this formula also, so that we'll be habitual with each and everything. Okay, so why don't we just find some results, or find some values using the formula. Let's just say I have to arrange n. Okay, I have to arrange r objects out of n objects. I have to arrange r objects out of n objects. So what am I going to do is I'm arranging the stuff of r objects out of n objects. So in short, what permutation says, pretty much similar to this, is that if you are arranging r objects out of n objects, so you just have to write in this way, and it is equal to, you are arranging how many objects in total? In total there are n objects. So we'll just take the n factorial over here n factorial, and in denominator we'll have, and in denominator we will have, okay, r factorial, this is minus and this is n. So there we are. Now let's just move on with some technical problems. What if let n is equals to 10 and r is equals to 5, then what will be my NPR? So n is my 10, r is my 5, so it's just 10 factorial divided by 5 factorial. That is what we have done it in the previous second last video, or whatever the video that was. It is 10 into 9 into 8 into 7 into 6 into 5 factorial divided by 5 factorial, and this 5 factorial and this 5 factorial gets cancelled. So I'm just left with this thing, 10 into 9 into 8 into 7 into 6. Now let's just take another example. Let me just take it down. Yeah, let n is equals to 5 and r is again equal to 5. Then what my NPR will be? Now I'll suggest you guys that pause the video and do it on your own. You just have to put the values. Everything is in front of you. So yeah, hoping that you have done. Let's just move ahead. So n is my 5, r is my 5, and in such case what I will get is 5 factorial divided by 5 minus 5 factorial, that is nothing but equal to 5 factorial. So in general, if the n is equal to r, then the permutation is in such a way that Pn, n or Pr, r, which is, but generally it is n, n, because we are arranging all the elements, all the objects. So it's nothing but equal to n factorial, and that is what the very first example of our permutation was. We are arranging 3 peoples A, B, C in, we were arranging 3 of them. So what we did was we calculated 3 factorial, and that is how we got there, since it was NPN. Let me just take it down now. Okay, now moving ahead, let n is equal to 5, r is equal to 4. Then what I'll have is now over here let me just do, there was 0 factorial, in sense 0 factorial is always equal to 1, so 5 factorial upon 1 is equal to 5 factorial. So I just forgot to mention this. Okay, now coming up to the next question, n is equal to 5, r is equals to 4, then in such case 5p4 will give me what? Again 5 factorial divided by 5 minus 4 factorial, it is again 5 factorial, upon 1 factorial is again 1, so it is again 5 factorial. Now why did I mention this? Because if n is equal to n or r is just less than 1, if r, or I would rather write in this way, it is in this way. If you are arranging n things, if you are arranging n minus 1 things out of n things, then you get again the same result as above. So in short, I can conclude that NPN is equal to NPN minus 1. This is what I wanted to tell you guys by using this. Yes. So NPN is equal to NPN minus 1. In both the cases, in both the scenario, what you got was the same answer, 5 factorial and 5 factorial. Now the things changes when you take r equal to 3 and 2, whatever you want to take. But that is the case. And again, the last case that we will discuss in this session, n is equal to 5, but r is equal to 0. Now what? Now since we weren't aware of, we didn't want to arrange anything. Let's just consider what I would say this kind of example in words is like, how would I express this kind of example in word is, I brought 5 books, and I'm not arranging any one of them. I just brought it and kept it. I don't want to arrange it. So how many arrangements did happen? None. There was 0 arrangement, and in such case what the answer will be 5p0, which is again equal to 5 factorial divided by 5 minus 0 factorial, and it is nothing but equal to 5 factorial upon 5 factorial, and it is equal to 1. It is equal to 1. And now this is why this is a real important scenario, because whenever there is a case where you do not do any arrangement, there is one possible arrangement, one possible case, and that case is you are not doing any arrangement. So you know we always wonder why anything to the power 0 is 1, and it has the application from this concept. उसका application यहाँ से आया. Now it says that, now ये जो yellow box में किया है मैंने, it says that how many possible arrangements are there in which I do not do anything. There is only one possible way in which you do nothing, in which you do 0 arrangement, and that is why you always get anything to the power 0 as 1, and since there were 0 arrangements, 5p0 will give you 1. 5p0 will give you 1. Now whoever tells you that a to the power 0 is 1 is just because so and so and so and so, you just tell them on their face that it's because of this. The very possible reason for this is that यहाँ पे possibility इसलिए आई है, mathematicians ने a to the power 0 को 1 इसलिए दिया है क्योंकि there is a way in which you cannot do anything, and that way is only one way in which you do nothing. थोड़ा confusing है वो, but it is what it is. So anyway, what I was going off the track a bit now. Yeah, okay. So what I want to say over here in permutation is, if you do not do any arrangement, then there is one way in which you do not do any arrangement. Okay. So this is also an important, concept. If you have, let's say, if you have n p 0, then you will always get answer as 1. That is what I wanted to tell you. So there are many results, but we'll keep in mind a few. Let me just zoom out a bit so that you can see all of them. Where are all of them? Yeah, over here I have written it anyway. मैंने यहाँ पे लिख रखा है. If npn, you have to find npn, then it is n factorial. If you have to find np n minus 1, then again it is also n factorial. If you find np0, then it is 1, and so on and so forth. There are so many beautiful ways in which you can prove so many beautiful results. Now let's just give yourself some task. These were some results that I wanted to show you. मैंने वो examples ही इसलिए लिए starting से, ये examples ही मैंने इसलिए लिए क्योंकि मेरे को ये result पर arrive करना था. Okay, this was the result that I wanted you to tell. Now, I'll give you some examples to work out. Let me just take it over here up. Okay. Now I need you to calculate np3, which is equal to 94. Find n. Now how would you do that? कैसे करोगे तुम ये? It's simple. It's n factorial upon n minus 3 factorial, which is equal to 24. And since I can rewrite this factorial in decrementing or decreasing format, and that is how, is nothing but n minus 1, n minus 2, n minus 3, and it goes on until 1. You stop it at 1. Now, but the thing is, I have to find it up to n minus 3 factorial only. Because in the denominator I already had n minus 3 factorial with me, and now this gets cancelled with this. What I'm left with is over here is 24, and now I'll have my answer of n. So my n into n minus 1 into n minus 2 is equal to 24. Let me just write it down in this different color. 24. And now I can I can solve this, and it's very simple. So how many possible n's are there? Now in factorial you cannot take the negative numbers. So you'll have to consider the positive number only. So find the values of n. Find the different values of n, and then by that you will be done. And how can you find the different values of n over here? using equations, using using factorization. This is a cubic equation, so it will have 3 roots for you. It will have 3 roots for you, and with those 3 roots, out of those 3 roots, only there will be a 1 or 2. How many numbers are there for n? To get yeah. So you will get a positive root, positive number, and that number will be the value of n. You will get 3 different values of n, out of which 1 or 2 will be the answer. But I am guaranteed, I am sure that you will get only 1, and the remaining 2 will not be the answer. And now, how do you find it? You know how to find the cubic equation. We are not going in detail for that. Okay, we are not going in detail for that. Now, you know what? We'll just take a few more examples. Okay, let me just erase it. Yeah. Now, a bit different example. A last example for this session. Now I guarantee this is the last example. Yeah, for sure. You need to find again n. Find n if what do we have over here is np13 is to what should I take? n plus 1. Let's take n plus 1 p12, and it is equal to 3:4. Yeah, let's just take this example. So what it is np13 is what? I'm separately solving it. So it is n factorial upon n minus 13 factorial. And what n plus 1 p12 is? N plus 1 p12 is, it is same, a bit different, I guess. A bit different. Let me just see what it is. I'll just do it downwards. Okay, let me just bold it down. N plus 1 p12, ये क्या होगा? n plus 1 factorial होगा divided by n plus 13 factorial. बरोबर? अरे 13 नहीं, sorry, 11. n plus 1 minus 12. So n plus 11 factorial. अब इन दोनों का डिवीजन लेना है मेरे को. ओके, इन दोनों का डिवीजन लेना है इस प्रकार से. तो ये बीच में डिवीजन आ जाएगा अभी. नाउ दिस इज वेयर द थिंग्स गेट्स ट्रिकी अ बिट. अब देखो यहाँ पे ऐसा ना लिखते हुए मैं इसको रेसिप्रोकल ले लूंगा, तो मैं इसको यहाँ पे मल्टीप्लाई कर सकता हूँ. येलो बॉक्स में जो थिंग है, येलो बॉक्स में जो कॉन्सेप्ट है, येलो बॉक्स में जो चीज़ है, उसका अगर मैं रेसिप्रोकल ले लूँ तो इट विल बी गेट मल्टीप्लाइड विद दिस, बिकॉज ये दोनों एक दूसरे के डिवीजन. ये जो पार्ट है येलो बॉक्स वॉज इन डिनोमिनेटर फॉर दिस पार्ट. ये जो भी कलर है उसके पिंक, लेट्स जस्ट कॉल इट एज मजेंटा और वॉलेट इट इज. ओके, सो ये जो फेमिलियर बॉक्स कलर लेता हूँ ना मैं, ब्लैक बॉक्स में जो थिंग है उसको मैं इससे डिवाइड करूंगा येलो बॉक्स से. सो इन अनदर वे टू राइट इट इज इन दिस फॉर्म. सो लेट मी जस्ट राइट इट आउट. इट n factorial divided by n minus 13 factorial, and that will be multiplied with the reciprocal of this concept. So it is n plus 11 factorial divided by n plus 1 factorial. And now to solve it, what I'll be having with me is, let me just take different color, n into n minus okay. What I will do is, I will not change n factorial, but I would rather change this over here. So वो क्या हो जाएगा? n plus 1, then I keep on decrementing, मैं decrease करते जाता हूँ एक. So n plus 1 minus 1 factorial. N plus 1 minus 1 factorial is nothing but equal to n factorial. Exactly, n factorial, and it is multiplied by, let me just write down this, n plus 1 factorial, not n plus 1, n plus 11 factorial divided by what it is, n minus 13. So over here, n minus 13 factorial. And now n minus 11 सॉरी n-11 आना चाहिए, यस n-11 आना चाहिए। क्यों? क्योंकि यू नो व्हाट, यहाँ पे मेरे से क्या गलती हो गई, n+1 -12 होता है, सो इट इज़ n-11, यस। सो दोज हु हैव फिगर्ड आउट इट इज़ माइनस, सो ड्रम रोल फॉर देम। जिन्होंने फिगर आउट नहीं किया रहेगा, सो इट डजंट मैटर। एनीवेज नाउ अब ये तो कैंसिल हो गए, यू नो ये और ये कैंसिल हो गया। व्हाट आई एम लेफ्ट विथ इज नाउ सी, यहाँ पे तो 1 बच गया। अब नाउ दिस ओवर हियर, इसको मैं डिक्रीमेंट करता हूँ एक कदम आगे, सो इट इज n-11 -1, so it is n-12, and again it is n-12, and it is n-13 factorial, and this gets cancelled, so numerator I am left with this. Okay, so let me just take this color and now write it down over here below as, यहाँ पे तो 1 आ गया, यहाँ पे ये कैंसिल होकर अब ये फॉर्म में आ जाएगा, सो n-11 n-12, यहाँ का डिनोमिनेटर गया लेकिन ये बच गया n+1, ओके n+1। now it is equal to what? It is equal to 3/4, so let me just use that information also. And now what we are going to do is we are going to cross multiply it, and we are going to figure out what the value of n is. So you know, what I will get is 4 times n-11 into n-12 is equal to 3 times n+1. And after solving this, what I will get is 4n square minus 95n plus 525 is equal to 0. After solving this, you will get this answer, and since it is a quadratic equation, I can find its root, and the roots are what are the roots? N equal to, you know, you can just pause the video and you can figure it out yourself. I have already figured out now, so yeah, n equal to 15 or n equal to 35/4. Now here's the thing, I have got a whole number and I have got a fraction. Now since permutation involves arranging of some objects, and objects are in whole form, वो कभी भी 3/4 नहीं रहते, ऐसे नहीं रहते, हम टूटे हुई चीजों का अरेंज नहीं कर रहे हैं, हम पूरी अच्छी चीजों का अरेंज कर रहे हैं। सो वी विल इग्नोर फ्रैक्शन पार्ट ऑलवेज, यू नो, हमेशा अरेंजमेंट में होल नंबर्स काम में आते हैं। सो वॉट एवर द एन विल बी, इट विल ऑलवेज बी अ होल नंबर. It cannot be negative, it cannot be fraction, but it can be 0 or positive. But 0 भी नहीं रहेगा, arrangement 0 object की हो सकती है, but n 0 हो गया तो there is no arrangement. So there will be 0 arrangement, you know. So n can never be 0, you know. We are not talking about 0 arrangements, we are talking at least arrangement of one arrangement, 2 arrangement, or how many arrangements are there. So n can never be 0 or negative or, you know, fraction. It should be a whole number only, and thus our n should be equal to 15. Our n should be equal to 15. If you will put the value of n over here, so 15p3 is to 16p12, it will give you 3:4. You can just check, you know, don't blindly believe me, just check it out whether the value n equal to 15 really gives you 3/4 or not. Okay, so yeah, this is how you are going to solve you're going to solve permutations using this formula. Okay, now we shall in next session move with some arrangement problems and those. Okay, so that's it from me guys, thank you.